Hi everyone. Thanks a lot for having me today. I'm happy to talk about our work on scaling real-time voice AI. And before that, I would like to say a few words about Kyutai. So Kyutai is a non-profit AI research lab we created in Paris 2 years ago. So thanks to the generous donation from Xavier Niel, Rodolphe Saadé, and Eric Schmidt, it's an AI lab that is focused on open research and open science. So the main mission is to make big advances in AI, in particular around multimodal LLMs. And the specific thing about Kyutai is that since it's a non-profit, all our inventions are published, shared in open source. We train PhD students, we collaborate with academia, and so on and so forth. And so what do I mean by scaling real-time audio? So you may be familiar with solutions. There are a lot of them around, like 11 Labs, Azure, and so on. And so currently, the main applications in AI voice are around offline content. So typically, you will generate an audiobook with a synthetic voice, or you would have a character in a movie that could say a few artificial sentences, or a small character that can, in a video game, also interact with you, and so on and so forth. So this is mostly offline content. So this is content that is highly qualitative and is generated as low volumes. A huge opportunity that is currently not really addressed is everything that is interactive and very high volume. So taking again the example of the difference between live content and the rest, when you make an audiobook, you can pay a lot, you can spend a lot of time iterating because you generate it once and it's consumed by a lot of people. On the other hand, there is a lot of content that is generated on the fly and needs to be processed right now and is consumed by a few people and then thrown in the trash. So for example, if you look at gaming, if you have interactive NPCs with whom you're going to talk, these interactions, there will be a lot of them. They are heard by a single person, and so they need to be very, very scalable, right? It's the same for robotics. Eventually, humanoid robots are going to play a huge part in our society, and interaction with them will be mostly vocal, right? So we're talking about lots and lots of volumes of audio, much more speech, AI speech than is currently existing. Same for media. Audiobook is massive media where you generate one audio for a lot of people. But now, when I show some examples, something that is starting to be a new product is personalized news, where you have your own news. Instead of consuming the same as everyone, you have some personalized news digest about your interest. It's the same. In that context, this is very focused on a single person, so you need to generate massive volumes of audio. And what does we look for when we mean voice AI? So the first thing is the kind of applications we are interested in. So people will naturally think about speech synthesis or voice agents, but there are a lot of things you can do. So synthesis is a task of you give a text and it generates the corresponding audio. Transcription is the fact of, on the other hand, writing what is being said. It's very useful, for example, for meetings and so on. Translation is translating speech in another language, most like hopefully in real time, conserving the voice and so on. Transformation is all the kind of audio effects you can do on a voice. So if you look, for example, at visual effects in even apps like TikTok, Snap, and so on, there is a lot of AI in it, right? So you can make a lot of AI-based transformation on your face. But the audio effects is like pitch up, pitch down, slow, faster. You know, it's not really using AI right now. So you could imagine much more richer transformation. And the last one is the full conversational experience, the voice agent. So now, when you have this set of capabilities, what are you looking for in terms of quality? First one is fidelity, right? So it needs to sound like if it was recorded in a studio and not on a smartphone in the subway. The second thing is you want to be able to design voices, either by cloning them or by writing natural language description, like I want a middle-aged man who smokes way too much and has a deep voice or something like that. You want emotions to be rightfully understood by the AI and also be produced consistently. So right now, you might be crying with your AI voice, and it's going to be like, oh, that's so great, and so on. So you know, it's not really exactly the kind of interaction you are looking for. The flow should be very natural. Right now, and I talk a bit about it, you need a lot of discipline when you talk to an AI, and so you'd rather want to have something that is, you know, much more natural, like a human conversation. Finally, the latency needs to be very, very low. And now about scalability, I think the two main challenges we are facing right now, and Paige say a few words about on-device models, sorry. If we want to scale audio generation to reach all the use cases I showed before in gaming, assistance, personalized media, and so on, Either we need to be able to generate very large-scale volumes on the cloud, or we need to be able to have small-scale generation on device, right? So let's say you want to make an NPC in a video game. Either it's hosted on the cloud, and you need to generate millions of hours of NPC voices, every month or so, or everybody is running on their PS5, the local TTS device, and so in that case, it's scaling through devices, right? So in particular, if you look at quality and scalability, there is kind of a trade-off where people currently have to choose. So if we take speech synthesis, again, very high quality, low scalability, the audiobook, right? You generate it once, it needs to sound very good, but you don't need to generate a lot of them, right? You make the Harry Potter's books, and you sell them, and you make a lot of money. On the other hand, voicemail requires a lot of scalability because everyone has their own voicemail. It's a interaction that you cannot predict, so it needs to be generated for everyone. But the quality can be pretty crap, right? If you call your voicemail, you don't need a full emotional understanding. You just want to know what people wanted to tell you. At the intersection of quality and scalability, there is a personal assistant. Now the content is not mass media. Everybody wants to have their own interaction, but they want it to be as qualitative as if it was the premium audiobook. So in that case, you need to nail both aspects at the same time. It's the same for translation. If you do diplomatic interpretation, really not our focus right now, because the expectations on reliability and accuracy are extremely high. Same if you are asked by, Netflix to dub a movie, the expectations on the quality are going to be very, very, very high. On the other hand, if you're translating, you want to be translated while you travel, it's a bit related to the recent release in the AirPods Pro. Then it's okay, I guess, if the quality is a bit lower, as long as it's useful and kind of reliable, and in particular can run on device, so you can bring it with you in your travels. And at the intersections of quality and scalability, you have meetings, phone calls, or small creators. So small creators is a bit like in opposition to movies. So in the case of movies, you make one movie for a lot of people. For small creators, the content is consumed by a few people, but there is a lot of content that is generated at the same time. So you need to translate much, much more content. Finally, for voice agents, one example I like is a startup working on airline claims. So if you do airline claims, it's like an AI that calls the airline and say, yeah, the flight was late by 1 hour, so you need to give us $300. In that context, if you pay $10 for the voice, it's fine, right? Because you get a lot of money. But now, if you have a bot at McDonald's that wants to take your order, it needs to be super cheap. But at the same time, the quality can be pretty crap as long as it takes the command right. And at the intersection, you have video game NPCs, interactive podcasts, e-learning. So if you want to learn a language through voice, not only it needs to be very cheap for you, because you don't want to spend like $500 a month to talk to it, but also you want the experience to be enjoyable and to be qualitative and so on. So you need to nail both aspects at the same time. So what I'm going to show is how you can address all these aspects and the story at Kyutai around them. So the first one is about quality. So the first project we did at Kyutai, called Moshi, it was about creating the first full-duplex conversational AI. It was more than a year ago, before the release of the advanced voice mode from OpenAI. Now it's something that people are used to have, conversational chatbots. All of them, without exception, even today, still rely on a half duplex setting. It's a bit like a talkie-walkie. So either the AI is speaking or it's listening, which means that it requires this discipline. So it's always a bit awkward when you talk to an AI, because if you interrupt it or you cough, it thinks you are interrupting, and so it starts breaking the flow of conversation, and so on and so forth. So it's not very natural, because you need to adapt to the limitations of the voice, rather than the voice adapting to the fact that, maybe you are erratic in the way you speak. Full duplex is the fact that the model always speaks and always listens. It can interject at any time. It can be interrupted at any time, exactly like in a human conversation. In a human conversation, if you're on the phone with a relative from your family, the amount of overlap speech is around 20%, which means that 20% of the time, people are speaking on one another, and that makes it, like a rich conversation in a way. And so how do we address that? That's a small technical part in this talk. We wanted also to address another aspect, which is that people rely on cascaded systems. So typical chatbot is speech to text, and then you have an LLM, and then you have text to speech. How can we merge all these steps into a single one? Because if we merge them into a single one, we don't lose emotional information, because we don't go through text, and the latency is going to be much better. So the way we did it is by taking inspiration from text models. So very quickly, a text model, text LLM, is a probabilistic model where you give a sequence of words and predict the next one. So Kyutai is you predict AI, and then you inject AI and predict research, and so on and so forth. So our main algorithm and the expertise of Kyutai is audio language models. How do you make an audio language model? The most basic thing you could do is say, OK, I'm going to put audio as input and audio as output of the LLM. It doesn't work at all for a very simple reason. Look at the sentence. Kyutai is an AI lab based in Paris. It's 8 words. So if you want to pass it into an LLM, it's very few tokens. It's around 3 seconds to pronounce this sentence. Even at 24 kilohertz, which is not studio quality audio, you get 72,000 values, which means that you have a super long sequence to pass through your LLM. And given that self-attention has a quadratic cost, so it's proportional to the square of the length of the sequence, it means that it's 100 million times more costly to process audio than text with an LLM. So what we did instead is that we invented Mimi. It's a codec. It's like an alternative to MP3 or Opus. It takes a large audio file, and it compresses it so densely that it's a bit like a text representation. In the case of the sentence I showed, instead of having 72,000 samples, you go to 37 tokens. So now, it's almost as if it was text. And you can just train an LLM to predict these tokens. Then your LLM predicts these audio tokens, and you have a decoder. It's a generative adversarial network, and it's going to reconstruct high-quality audio from it. So now we have turned the task of audio generation into a task of language modeling. And in particular, that's the main standard architecture used by Google, OpenAI, and so on for modeling conversations. And the way they do it is that they have an audio LLM, and they have this sequence of audio tokens that either represents the LLM or the user. So in that context, the model is going to predict the next turn based on the previous turn. It works nicely and can give all the chatbots that you have right now. But it's still a talkie-walkie, because it's either the model is speaking or the person is speaking. So what we did is we invented what we call multi-stream modeling. It's a very simple idea. We just have 2 streams in parallel, which means that both can be speaking at the same time, both can be silent at the same time. One can talk and the other around. And what it gives, and I'm going to show you, it's the demo we did more than a year ago now at IRCAM. You're going to see 2 things. The first thing is conversation with Moshi, where you're going to see that the model has still the lowest latency latency at this point. Sometimes when it guesses where you're going, it starts answering before you're done. You're going to see Alex speaks at the same time, and there is no problem with this ambiguity where both are talking at the same time. And the second video, it's me during work in our office, where it's super noisy, and its good advantage of full-duplex models is that since they don't have this awkward handling of speaker turns, you can have a lot of background noise, and they just work pretty well.
So the planet is Sirius 22. Can you plot a trajectory course to it, please?
Yes, sir.
Okay. How long is it going to take us to get there?
I've mapped it out.
Okay.
It's approximately 5 months to get there.
Okay, that's not too bad. Do you think we have all we need on board the ship to start the mission?
Yes, sir. We have everything we need.
Okay.
Good day. How are you doing?
Hey, I'm doing some construction work right now, as you can see. I'm looking for some advice. Can you help me with that?
Sure. I'm happy to help. What's the issue you're facing with your project?
So in that context, I couldn't even hear anything, and the model has no issue handling noise. The second thing we tackled is capability. So the multi-stream architecture we invented is not an architecture only for dialogue. It's basically a general framework for modeling any kind of audio task. In particular, if you take your 2 streams, and instead of having the LM speak and the user speech, you can have me speaking in French and me speaking in English. And now you can predict me speaking in English from me speaking French, and you get real-time speech-to-speech translation.
Bonjour à tous. Je suis ravi de pouvoir m'adresser à vous aujourd'hui en français, puisque
Hi
mon téléphone
everyone,
va se charger
I'm
de
delighted to be
traduire
able
ce que
to
je
speak
vous
to you
dis
today
en
in
anglais.
French since my
Comme vous
phone
pouvez le
will
voir, il est en mode avion.
translate
On
what
n'a
I
pas de
am
connexion
telling you
Internet,
into English.
parce que notre
As you
modèle
can
de
see,
traduction
it is in
automatique
airplane mode.
permet de
It
faire
doesn't
la
have an
traduction
internet
de voix
connection
en temps
because
réel,
our
entièrement sur
machine
téléphone.
translation model
Vous
allows for
pouvez trouver le modèle en
real-time
téléchargement
voice
libre sur
translation
Hugging
entirely
Face
on the
ou sur
phone.
notre GitHub. Je
You
vous
can
invite
find
à
the model for
essayer.
free
Pour
download on
l'instant,
Hugging
il
Face.
supporte.
So in this context, this model was made by a single master intern in a few months, because since it's the same architecture, just generate new training data, and it's very easy to go from conversation to translation. It's again extremely robust to noise.
My name is Alexandru, and I am testing this model in extreme conditions. At this moment, there is very loud music, and I can barely hear what I'm saying. However, our model is able to translate live.
So it's Kavinsky behind. You cannot probably recognize him, but anyway. So this is for translation. Again, you can. There is a live demo coming and everything can go wrong, so please bear with me. From translation to transcription now. So, okay, I showed two tasks. Now, instead of predicting English from French, you can predict text from speech. And in that context, basically, the idea is the following. So it's still the same architecture, but now what it can do is real-time transcription. So at the moment, it's the most accurate and fastest real-time transcription in the world. It's open source. And the way it works is it predicts in a continuous fashion the text from the speech. And so this, par ailleurs, ça marche aussi en français. Ça supporte ce qu'on appelle le code switching. Donc vous pouvez parler dans les deux langues et puis ça va bien retranscrire. And now I can go back to English and it's going to work, hopefully, I hope so. Okay, first demo, okay. Back to the presentation now. You can also do it the other way around. So instead of predicting speech from text from speech, you can predict speech from text. So it's, in that case, streaming text to speech. So text to speech, there are a lot of them out there. The specificity about this one is that it's streaming on text, which means that as you type words, they start being generated. It's useless for a human because it will be super weird for typing and start speaking. But when you want to make it work with an LLM, it's very useful that, let's say you want to make a conversational agent from an LLM, and the LLM is going to produce a huge paragraph. You don't want to wait for the LLM predicting the paragraph to start predicting the audio. You want both to be predicted at the same time. So in that context, what you're going to see is the actual real-time latency.
Coming up next, we've got something special, the AI Engineer Paris after party. Enjoy drinks and fruitful conversations. See you next time.
Please stay. It's not. I should have put it at the end of the presentation. So it's not. It's not. Please, a few minutes more, and we can have some drinks. And interestingly, so there was a nice talk earlier by our friends at Pionot. But again, instead of predicting just text, you can also predict text with the label of who is speaking when. So if you have a meeting with a lot of people, you want to be able not only to transcribe a single stream of text, like is often done, because it's hard to parse, but rather having the model detect who is speaking and associating the right transcript to them, all of this still in real time.
Understand that?
Yes.
Okay, I tell you, if you need to tell me something, I'll let you come up here to the podium so you can speak into the microphone and I can hear you.
Yes, the attorney here, I'm wanting to fire him.
Uh-huh.
And, I don't feel like he's doing any...
Who are you going to hire?
I'm not going to hire nobody. I'm going to try to get a different public defender.
There isn't... You have a right to an attorney.
Yeah, anyway, so, I don't want to put too much content because otherwise it's going to be strike. But anyway, so that shows the flexibility of this model. And now, what you can do is you take the real-time speech-to-text and a real-time text-to-speech, and you can put an LLM in the beginning. So in a way, we are back to what I showed before, which is the cascaded system. So it has more latency, and it's not speech-to-speech, but the very nice thing about that is that it's completely customizable. So you don't have to touch the LLM. So you have a LLM with like a vision, understanding, and function calling, and tool use, RAG, whatever you name it. Most people, they just want to make it speak. They don't want to train a new model that is completely replacing their text stack. So in that context, and that's going to be the demo that worked perfectly during the rehearsal and started freaking out 30 minutes ago, so let's see. In that context, the way it works is, for example, I can put upload a 10-second sample. So in that context, I uploaded a voice sample from Général Charles de Gaulle, from l'appel du 10 juin. And I write a personality to the LLM, so just a prompt explaining that I'm talking to Général de Gaulle. And now you can have like design with a 10-second sample and a very short text, a new conversational experience, basically.
Je suis Charles de Gaulle, général de la France libre. Je suis ici pour partager avec vous des moments historiques et des réflexions solennelles.
Bonjour, mon général. Est-ce que vous m'entendez?
Oui, je vous entends parfaitement. C'est un honneur.
Excuse me, my general. For the sake of the audience who is mostly English speaking, maybe you can switch to English. So right now I'm giving a talk on audio language models And I was thinking maybe you could have some advice for me. Maybe you could try explaining it in your own words.
Ah, bien sûr. When I think of language models, I am reminded of the importance of communication during the darkest days of World War II. We had to convey messages clearly and with conviction to unite the French people. In the same way, these models must be precise
Okay,
and
thanks
compelling.
a lot, my general. Thanks a lot.
Let's
Have a
find
good
out.
one. And so finally, the last one is about scalability. So the demo I showed of the on-device speech-to-speech translation, you can also run it on the cloud, and on a single H100, you can process 320 concurrent conversations. That means that on a single GPU, you can serve hundreds of concurrent conversations. Similarly, if we look at our speech-to-text and text-to-speech, so our text-to-speech in terms of streaming solutions is more accurate than Whisper, for example. And the throughput, it's the number of seconds you can process in 1 second, right? That means that we have like a 400 times real-time factor against a 5 times real-time factor for Whisper streaming. Same for our TTS, that is open source. If we compare to the main open source TTS, Orpheus, Dia, CSM, Chatterbox, we have more than 100 times higher throughput, while having a smaller word error rate, which means that we have better pronunciation and fewer errors. What that means is that now you have something that can scale to address all the applications that I've started describing. Because now if you want to make NPCs in video games where everybody is going to have 20 villagers they can talk to in a huge open world and so on, it starts to become believable, which was really not the case until now. And to give you a final idea of just a final demonstration of this, you can, as of today, on La Provence, listen to a news article with our voice.
De l'offensive israélienne à Gaza.
Ce mercredi 24 septembre, des dizaines de Palestiniens ont été...
So, yeah, probably not the best topic, I really apologize about that. But here what you see is the difference between two types of media. What I just played is the journal for everyone, right? So that's kind of the audiobook. It's a single media generated for everyone. On the right, unfortunately, it's not available on the web yet, it's on the app. It's a personalized news digest. So in that context, there is only a solution like ours that can scale to generate for each person reading a journal their own news stream. So basically, our goal is to go and remove the trade-off between quality and scalability and provide both. And in particular, what we have been doing with La Provence for incorporating our models into products is the kind of collaborations we are as well looking for right now. So you can find all our code on GitHub, our pre-trained models on Hugging Face. We publish all our research on archive and in conferences. So all of this can be found. And we are interested maybe in opening limited access to an API that we can serve to people who want to try to prototype large-scale audio generation. So what we're excited about is if someone wants to make a video game with NPCs, with voice, or someone wants to automate customer support for something, or create an education app, and so on, super interested in this kind of use cases, so please don't hesitate to reach out. This link brings to a Google form where you can reach out to us. Thanks a lot for your interest. Thanks a lot for bearing with me. Yeah, thanks for your attention.